Welcome, viewers, to the Daily Space Weather. Let's get right into it. We had a little proton event happen, as well as an M-class solar flare and associated coronal mass ejections. Spectacular imagery here from the SDO. That and lot more coming in today's Daily Space Weather. Let's play some tunes and show some additional solar imagery. Sunspot 2895 has degraded significantly over the past 24 hours. The solar flare and coronal mass ejection and relativistic protons, indeed, came from around the limb of the sun up here. A sunspot that's already set. Here's your colorized magnetogram, and that southern sunspot has remained stable. So has this northern one. 2895, once again, has degraded a bit. There's your full disk colorized magnetogram from the Solar Dynamics Observatory. Here's a close-up in 171 angstroms. Just a great wavelength to show the lower corona. It's ionized iron. It's a little on the hot side. Here's a different ionic state of iron. This is 94 angstroms. And we've got close-ups of that wavelength to show you at the end of the video. Just spectacular. Here's another ionic state of iron at very high temperatures. This is UV light, by the way, folks. The Solar Dynamics Observatory AIA images are all images of the chromosphere. And parts of the corona. The 10.7 centimeter radial flux has come up a bit here. It's now up to, I think, 92. Here's the one-year chart of the radial flux. That's waiting to be refreshed here at solon.info. Yeah, 92 solar flux units is the current state of the 10.7 centimeter radial flux, the most proportional data set we have to sunspot number, which is the red line down here. The black line is the 10.7 centimeter radial flux, and you can see those spikes getting bigger as solar cycle 25 progresses. No space weather storms or geomagnetic unrest currently in the forecast from NOAA on the Space Weather Enthusiast dashboard. Let's talk a little bit about global seismicity. Check it out. This is a approximately 5-month 7 magnitude earthquake drought back in 2017. And if you look at other years, especially, as there was quite a very low number of earthquakes. Oh, that's 2020. That's 2017. All right. So 2018, you see there was a big drought in that year as well. 2019 featured an earthquake drought between July and November. And last year we covered one toward the end of the year. So there's the current year to date. And we're getting into another earthquake drought. So there's the past 90 days of global seismic activity, major quakes only shown there. And let's see what we have on the list at the USGS. So yesterday we reported on a 6+ magnitude quake near Nicaragua. Today, nothing even in the high 5 range, I think. So if you're in an earthquake-prone zone, please have a plan in case buildings start to collapse. If you're going to evacuate, especially an urban building, know which building facades might collapse. If you're exiting yours to the street, if there's an old building or something like that that's got a in disrepair looking facade out front or something, that could come down. So just be aware of that. An ounce of prevention is worth a pound of cure, right? No significant earthquakes to really report on here, folks. So this is like one of the least seismically active reports we've done in pushing 4 years of daily space weather videos. Check it out. It's Halema Uma'u's lava lake in thermal imagery. You can find it on volcanodiscovery.com's Volcanoes Today page. La Palma is still erupting. It's producing an 8,000-foot ash plume as it explodes. That's the Canary Islands, if you're new to the channel. And here's some footage of lava flowing into the sea, I think.
18:10 en zona, seguimos personal.
Just insane footage there. Those folks are looking a little bit close. I don't know if I would prefer to be that close. And perhaps producing some VOG there as it flows into the ocean. Some great lava flow imagery there. Some glowing lava rocks there cascading down the side of the slope. Karimsky also exploding, 12,000-foot ash plume over the Kamchatka Peninsula from Karimsky, and now Kilauea showing up on the list. Again, we showed you the thermal imagery of Halema Uma'u. The effusive eruption within the lava lake has picked up again since around the 4th of November. And there's a time-lapse video. Let's check it out. All right. Thermal time-lapse imagery. So awesome. By the way, later this year, we will be getting a thermal camera to produce more and more interesting content on the channel. So make sure you subscribe if you haven't already done so. Fuego also exploding, producing a 15,000-foot ash plume over Guatemala. Nevado del Ruiz, flight level 220. It's a 22,000-foot ash plume as it explodes in Colombia. Revenador exploding, 15,000-foot ash plume over Ecuador from the Revenador volcano. Sabancaya exploding as well, 24,000-foot plume of volcanic ash. Please don't pole vault the caldera. Please do Make America Not Suck Again. If you're viewing the videos from the U.S., Make America Not Suck Again. If you're viewing the videos from international locations, or perhaps from a different dimension, timeline, galaxy, multiverse, universe, plane of existence, etc., make Earth not suck again. If you've got any ability to do so, please help us out in our efforts to make Earth not suck again. And for you Americans out there, make America not suck again. Mansa. Pick up some products. They make great gifts, by the way. You can save 20 to 60% store-wide by using the promo code YWAIT on checkout. Here are our designs, sorted by best-selling. Thanks to everybody who's picked up merch. You're increasing the probability that these videos will continue to exist, be publicly visible, and free for all to view. At the moment, these videos are in danger of coming down at any moment. Only the slightest hiccup could take down our channel forever. So please support us via links at smashomash.com. So that one can be found at smAsho merch. Also join the Smash team. I'd show you what's going on Smash team, but we've just put up a post for gold members only. So we can't really show you it during the video. That post is for paid subscribers. Next, looking at the GOES magnetometer here, seeing some very low numbers. GOES magnetometer making it all the way down, at least the GOES 16, all the way down to 47 nanotesla. It's a pretty low reading there. And also we're seeing a divergence happen here. The GOES 16 measuring higher readings and the GOES 17 sort of flatlined there in the last couple of hours. Let's look at more magnetic data like the heliospheric current sheet. Earth remains in a South Pole current sheet. I would not expect us to be in a North Pole current sheet anytime soon. Just keep in mind the magnetic environment can suddenly change. You never know when a sunspot's going to grow or shrink, for example. Next, the line of sight plot. It shows you the solar magnetogram. It gives you insight into the BZ component of the solar wind. It has to do with where this blue line is located. Again, Earth in a South Pole current sheet. No changes to that coming in the near future, or at least in the foreseeable future. Next, looking at the coronal hole line of sight plot, and you can see a pretty major South Pole oriented coronal hole here, just moving up into the trans-equatorial region, as you can see right there. That has crossed the solar equator there. That could be a major geo-effective coronal hole. We'll be looking at that as that rotates around, slightly becoming visible down here in the southeast. That's your coronal hole visual from the SDO 193 angstroms wavelength. Next, we're going to show you the coronal mass ejection from both stereo A, located at Lagrange point 5, and the LASCO C3, located at Lagrange point 1. Here are those on the left and right, respectively. Again, stereo A out here at Lagrange point 5 is on the left. The LASCO C3, located at Lagrange point 1, is on the right. Looks like some relativistic particles struck stereo A before even any ejecta came out. Check it out right here. That looks like those are cosmic rays directly from the sun, folks. Likely relativistic particles, as they're right before we start to see the CME erupt there. It is not Earth-directed, folks. You can see all of the ejecta appears to be off to the west of Earth. If this were an Earth-facing coronal mass ejection, we would see like a halo on the LASCO C3. If you're wondering what this is here, folks, that's the planet Mercury. So here's that solar flare we were talking about. It was an M-class flare. The peak flux was around 1700 yesterday on the 9th of November. It did provide some relativistic particles. We'll show that on the next frame. And there you can see this proton strike. It only took about 4 hours. It took about 4 hours for those relativistic electrons to show up. They weren't moving nearly as fast as the ones that showed up from that X-class flare, the most recent X-class flare. And they're subsiding much more quickly. It was a very minor proton strike. The deabsorption regions are not featuring any continued high-frequency radio blackouts. So there's no continuing polar radio blackout going on at the moment, folks. We're not even going to show the graphics. We're moving straight to the real-time solar wind, and we are seeing indeed a coronal hole wind stream here. Sort of taking its time. It's we never saw a very high density, only making it up to about 15 protons per cubic centimeter there. Speed only reaching about 450 so far. I wouldn't expect to see that ramp up that much higher, as the coronal hole associated here was pretty diffuse. Not a super well-defined coronal hole. Anyway, current conditions are 6.04 protons per cubic centimeter for the solar wind density. Solar wind speed 439 kilometers per second. Slightly elevated, and it has the characteristics of a coronal hole high-speed stream. KP index at 3 here over the past most of the last 12 hours there. Each bar there represents 3 hours for you new viewers, and the KP index is a measurement of global geomagnetism. Let's look at geomagnetism in space as modeled by the Space Weather Modeling Framework. It's the last 4 hours of magnetohydrodynamic pressure around the Earth geospace. Fairly homogeneous here, no real major changes going on in the last 4 hours. This data courtesy University of Michigan. We'll also show you ground magnetic perturbations, changes to Earth's B field at the ground level, giving you additional insight into what's going on with Earth's polar excursion. You shouldn't be scared of it. If you are, you've probably been convinced of nonsense on YouTube, or who knows where, but there's certainly plenty of hogwash, poppycock, and malarkey on YouTube. We don't produce any. We're seeing some geomagnetic pulses here coming out of equatorial regions, something more common when we do have ongoing proton events. But in any case, I'm going to let this play through a second time here, as we see a little bit of anomalous stuff going on. So some changes to Earth's B field happening here over Southeast Asia, as well as the Pacific Ocean. They're pretty minor, and again, we saw these similar type of magnetic pulses associated with the last proton event. These are more minor and are giving us additional insight into what goes on with Earth's Van Allen belts. By the way, to our Gold Smash Team members, go read the PDF document, or maybe even order the book that we recently linked to at smashomash.com/smashteam. Again, that's only for Gold members, folks. You got to pay us $9.99 a month to see all of the content, or you could do a paid-up annual membership for $109.89, which is by far the best value. It'll save you about $40, since you'll get some complimentary merch and a free month figured right into the price. smashomash.com/smashteam. Here's a diagram of the solar system. If you're wondering where stuff is, here's where it is. Mercury is making a pass to blow past Mars like it's standing still. Let's show a 7-day forecast. Here's where things will be in 7 days, approaching another full moon. And we like to be comprehensive and condense a lot of information into the videos. So here's a star chart. I use in-the-sky.org. Mine faces the south. We've also drawn in the ecliptic, which is the yellow line, and the blue line, which is the galactic plane. Today the sun will be going through Virgo and Leo and Gemini and Taurus and setting around Aries. Did you know? Did you care? Do you find it relevant to anything? Is cosmology looking more and more like astrology as time goes on? Next, we're going to show you your detected sunspot groups and flares probability. Notice yesterday's video had a solar flare warning right in the thumbnail and in the title. 2895 still capable of producing major flares despite degrading over the past 24 hours. 3 major sunspot groups, only one likely to produce significant flares. It's 2895. These two are both alpha class, so while they're rather large umbrae, they're not magnetically complex. Let's do a cosmology segment. This one once again is integrated into the daily space weather video. Check our playlists for over 200 more cosmology segments at youtube.com/smashomash/playlists. Today's random number is 190, which coincides with a massive radio source believed to be a, quote, black hole, and, quote, known as Large Magellanic Cloud X1. It's a massive radio source located in the satellite galaxy of the Milky Way known as the Large Magellanic Cloud. There are the X-rays from it daily over the past 16 years and over the past 30 days. And let's see how black that hole is. So here's the black hole in infrared. This is the 2-mass imagery. And this is the Large Magellanic Cloud right here. And so this massive radio source is on the outskirts of the Large Magellanic Cloud, as you can see. And as we zoom in infrared light, it looks pretty hot around that black hole. Let's see how black it is. So that was infrared. Here is optical. It's the DSS2 colored imagery. Certainly a rather bright portion of space there. Not looking particularly black in optical wavelengths. And we just don't have very much imagery on this one. I would note once again that this is item number 190 at the Neil Gehrels Swift-Bat X-ray Observatory. If you want to go read more about the Large Magellanic Cloud massive radio source known as, and X-ray source known as X1, just click on SIMBAD. You'll find a link to the CDS portal. And this is actually bright across a significant portion of the electromagnetic spectrum, as you can see there. And there are quite a few articles about it. The massive radio source known as X1, LMC X1, located in the Large Magellanic Cloud. And I think there may be more imagery of it here. It's just not showing up on the CDS portal. Are you familiar with green flashes? Sometimes when the sun sets and rises, it produces a green flash. It's not because the sun has turned green or anything like that, folks. It's because the Earth's atmosphere is behaving like a prism. And actually, here's LMC X1 in X-ray. That's the Chandra. Quite high resolution imagery there from the Chandra X-ray survey. And back to the green flash. Again, green flashes are caused by a prismatic effect in the Earth's atmosphere. Earth's atmosphere refracts the light, causing that green appearance. You can also see it at sunrise sometimes. That's the astronomy picture of the day at apod.nasa.gov. That's today's cosmology segment. Let's blast through more data. We don't want the video to be too long. Charging hazards are minor. There are some over southern Mexico, most of Mexico, some of Central America, and moving into the Central Pacific as we speak. Here's the relativistic electrons over the past year reported by Solon.info. And we've seen a dip here. Maybe not going to see warning levels again today. I have no forecast for that, but there's the 3-day chart as measured by the GOES 16 and GOES 17 Van Allen belts. Next, the relativistic electron forecast model. And we're expecting a dip. I would tend to agree with that, as there is a coronal hole wind stream currently striking the earthly geospace. Here's the diagram of Earth's Van Allen belts. Distances are shown in miles because we're showing you the total electron content forecast. And we're seeing once again some anomalous electrons here over places like North America and Canada. Of course, Canada is part of North America. Also seeing some chaos here. Usually we see more organized bands around the equator at noon, so a little bit of disorganization happening there in the electron belts. Here's another diagram of the atmosphere because we're showing you the F ionosphere layer next. And here's the F ionosphere, the vibrational frequencies therein. And we're seeing continued anomalies here. We like when we can correlate anomalies with the electron flux and the ionosphere. It gives us continuity in the physics. Anyway, here's the anomalygram. This is the anomaly in megahertz from the 30-day median. High-frequency anomalies are shown in red. High-frequency anomalies are shown in blue. Low-frequency anomalies are shown in red. Quite a bit of anomalous behavior around the central part of Africa. Right about here, we're seeing like some sort of a, perhaps giving us insight into a feature here in the African Rift Zone, maybe giving us some features by looking at the weather in space of what's going on inside the Earth. What do you think? Let us know in the comments. There's the latest vibrational frequency diagram, the ionogram from 10:45 Universal Time. And there is the anomalygram, the departure or anomaly in megahertz from the 30-day median. And here are our bonus features. It's the El Teide Ground-Based Solar Observatory looking at 6,562.8 angstroms. Hydrogen alpha. That's the ultraviolet wavelength spectra of hydrogen. Yes, the sun. It's got a lot of hydrogen. Anyway, we've got some filaments here, once again in the northeast as well as the northwest. Quite a bit of filaments around the entire western limb, really. Here's your latest intensity gram. We just pressed refresh. Again, 2895 is degrading rather rapidly. It still does have sufficient fields to produce significant flares. There are the fields. The other two sunspots are fairly unremarkable here and not magnetically complex. What is magnetically complex was this activity. Yowzers. So we've showed you a whole bunch of different spectra today, folks. We hope you enjoyed the spectacular imagery. Once again, congratulations on realizing the channel exists. I don't know how you did it. And let us know how you started watching the channel in the comments. Even if we already know, just leave us a comment for no reason at all. Leave a comment telling us what you think about YouTube, Facebook, and Twitter's pathetic censorship. Here's a composite. This is ionized helium and iron. 304 and 171 angstroms. I think this is officially my favorite composite view because it shows so many features. It's just spectacular. And we'll close out today's daily space weather with ionized helium alone, 304 angstroms from the Solar Dynamics Observatory. Thanks again for tuning in, and may that solar wind be at your back.